And on to the next 4 questions. Question 4, write 2,350 million in standard form. There are several ways I could do this. The nicest way to do it is to know that 1 million is 10 to the 6. That's 1,000 thousands. So I've got 1 million is 10 to the 6. And then to write 2,350 as 2.35 times 10 to the 3. Remembering that standard form is in the form a times 10 to the b, where a must be between, but not equal to, 0 and 10. In other words, it must be a single digit whole number. So 2.35 times 10 to the 3 times 10 to the 6 is 2.35 times 10 to the 9. Alternatively, I could write this out with lots of zeros, 2,350 and then 6 more zeros, and count back 9 zeros to get 2.35. But I think that's a more elegant solution, and also more in line with what you would do in science with giga or mega or nano, and so on. Second question is the other way round. Write 25 times 10 to the 6 in standard form. I'm using the same definition here. A must be between 0 and 10. It's not at the moment, so I have 2.5 times 10 to the power of 1. That's 25 times 10 to the 6, which is 2.5 times 10 to the power of 7. And finally, which of these numbers is a square number? A square number is one where I can write my number in brackets, square it, and then get my number. So in the case of 4 and 9, both of those are square numbers. 2 squared is 4 and 3 squared is 9. But if I look at my powers of 10, 10 to the power of, well, I guess 2.5 is 10 to the 5, but that doesn't really work here. 10 to the power of 2 squared is 10 to the 4, that seems good. 10 to the 1.5, 10 to the 1.5. So the only one I can write as a square number is b, which is 3 times 10 to the 2, all squared. Everything else you have a non-integer, that is non-whole number, power of 10 inside your brackets, so not a square number. In the same way that we say 3 isn't a square number because I can write it as root 3 all squared, but that's not an integer. Question 5, the terms in this sequence increase by the same amount each time. In other words, it's an arithmetic sequence or a linear sequence. Work out the missing terms. So let's say I'm adding an amount d each time. So 17 to here, I've added d, then I add d again, and then I add d again. So 17 plus 1d plus 2d plus 3d is equal to 29. 17 plus 3d equals 29. So 3d is equal to 29 minus 17, 12. d is equal to 4. So 17 and I add 4 gives me 21. I add 4 gives me 25. Going the other way, I'm now going to subtract d each time. 17 subtract 4 is 13. Subtract 4 is 9. And I found my missing terms. And I can just check, add 4, add 4, add 4, add 4, add 4. It's going up by the same amount each time. Seems good. Work out in terms of n the nth term of the sequence. So we know it's arithmetic or linear, so that means I have my common difference 4 multiplied by n, where n is the term in the sequence, and then I need to add my 0th term. That's the term that would be here if it existed. You may hear that called the ghost term by some people, but not me. So that would be 4n plus 5, because if I subtract 4 again, I get plus 5. I would just then check my answer makes sense. If n is 1, I have 9. If n is 2, I have 13. If n is 3, I have 17. If n is 4, 21, and so on. So I know, therefore, my answer is correct. Question 6 asks you to find the equation of that line. It's a straight line, so it's in the form y equals mx plus c, where c is the y-intercept. So in this case, the intercept is 0. It goes through the origin, so where y is equal to 0. And m is the gradient. M is the change in y over change in x. Now to find that gradient, pick 2 points on your line. It doesn't really matter which two we choose. I'm going to choose the origin as one because it makes my life easier. And I'm doing y2 subtract y1 over x2 subtract x1. It doesn't matter which way around you choose 2 and 1 to be, as long as they're the same for both the y value and the x value. So let's go with 1 and 2 just left to right. So y2 is 4, y1 is 0, x2 is 8, x1 is 0, so my gradient is 4 over 8 is 1/2, and therefore y is equal to 1/2 x plus 0, or just 1/2 x. Just to check that, I'm going to substitute in x equals 10, y is equal to 1/2 times 10, 5, x is 10, y is 5. Seems good to me. And that's the next 3 questions. Sorted.